topic of this video is building quadratic models from verbal descriptions, economic models. This is a continuation of the previous video. Alright, so in our previous video we looked at this problem and we created a function that expresses the revenue R as a function of x, which we will need as we continue parts D and E. Part D, what quantity x maximizes revenue? What is the maximum revenue? Part E, what price should the company charge to maximize revenue? Okay, so the first thing you should think of when you see a word like maximum is, am I dealing with a quadratic function? Because if you're dealing with a quadratic function and you're looking for an extreme value like a minimum or a maximum, you're looking for the vertex. Well, this is a quadratic function. The highest exponent of x is 2, and it meets all of the other conditions for a quadratic as well. So with this in mind, we know that the vertex x formula is going to help us solve this problem. So let's go ahead and use it. We know that for this particular quadratic formula, the coefficient of x squared, a, is equal to negative 1/6, and the coefficient of x, b, is equal to 100. The vertex x formula says that we'll have a minimum or a maximum where x is equal to opposite b over 2a, which in this case is equal to opposite 100 over 2 times negative 1/6. This can be simplified as negative 100 over 2, which can be written as 2 over 1. So now we can go ahead and multiply these two fractions. You should always check to see if you can simplify before you multiply. 2 goes into 6 exactly 3 times. So 2 over 6 can be rewritten as 1 over 3. So with this in mind, I've got 1 times 1 for the numerator, 1 times 3 for the denominator, and a negative sign. Okay, continuing to simplify. A negative divided by a negative is a positive, which means I could drop both negatives and simply figure out what is 100 divided by a third. Now I'll keep change flip to get my answer. Keep the 100 just as it is, change the division into multiplication, flip this so that it becomes 3 over 1. 3 over 1, of course, is just 3, and 100 times 3 is 300. So, this answers the question, what quantity x maximizes revenue? We need 300 units produced and sold. The next question for part D says, what is the maximum revenue? Well, now that we know the value of x that will create the maximum revenue, to get the revenue itself, we simply have to plug into our function. So we're going to find r of 300. And r of 300 will be negative 1/6 times 300 squared plus 100 times 300. Order of operations says that I have to do exponents first. So negative 1/6 times 300 squared. Ignoring the zeros for a moment, 3 squared is 9. And then you've got 2 zeros, and then another 2 zeros because you're squaring it. So that'll be 90,000. Okay, now we'll do the multiplication. So I need to do negative 1/6 times 90,000, and I need to do 100 times 300. Well, this 6 is in the denominator, that's dividing. So I've got 90,000 divided by 6, which is 15,000, and then multiplied by 1, which is still 15,000, and then made negative. So this is negative 15,000. Plus, 1 times 3 is 3, and there are 1, 2, 3, 4 zeros. Add the numbers together, and we get the revenue of $15,000. Okay, that's it for part D. Part E, what price should the company charge to maximize revenue? Well, this is actually very easy if we remember two things. First of all, x is 300, r is 15,000, and x, r, and p are all related by the equation r is equal to x times p. So let's plug in the r and the x into this equation, and then we'll be able to solve it for p. We get 15,000 equals 300 times P. Divide by 300 on both sides. P equals 50. And because it's a price, we express it in dollars. Okay, so the company should charge $50. When they do, they will sell 300 units of the product, which will bring them the maximum revenue of $15,000. We've completed this problem.